Welcome to NexCurious, your guide to the tech frontier. Today, we're unraveling one of the most intriguing concepts in modern technology, quantum computing. Curious to dive in? Let's explore.
Welcome to today's episode of Notebook Insights, where we dive into some of the most fascinating tech shaping our future. Today, we're taking a journey into the world of quantum computing. You might have heard the term before, but what exactly is quantum computing? How does it work, and why is it so significant? Let's break it down together in this introductory guide, Quantum Computing 101. First things first, what is quantum computing? At its core, quantum computing is a new way of processing information that uses principles from quantum mechanics, a branch of physics that deals with the behavior of particles on the smallest scales. To understand quantum computing, let's compare it to classical computers, the devices we use every day. In classical computing, everything is based on bits. Bits are like tiny switches that can be either in the on position, represented by a 1, or in the off position, represented by a 0. Every piece of information, every calculation, every app you open, all of that boils down to a long series of these 1s and 0s. In this way, classical computers are pretty straightforward, they process information sequentially, one bit at a time. But quantum computers work differently, thanks to a special unit of information called the qubit. Unlike a bit, a qubit isn't limited to just 0 or 1. Instead, a qubit can exist in a state of 0, a state of 1, or both states simultaneously. This ability to be in multiple states at once is known as superposition. Now, superposition is where things get really exciting. Imagine that a classical computer has to analyze every possible solution to a problem one by one. But a quantum computer, because of superposition, can analyze multiple possibilities simultaneously. Think of it as the difference between a single highway lane and a multi-lane superhighway. With superposition, quantum computers have the potential to tackle certain kinds of problems exponentially faster than traditional computers. Beyond superposition, there's another crucial phenomenon in quantum computing called entanglement. This is one of the strangest yet most powerful aspects of quantum mechanics. When qubits become entangled, their states become linked, no matter how far apart they are. In other words, if you change the state of one qubit, the state of the other qubit will also change instantly, regardless of the distance between them. This entanglement allows quantum computers to perform incredibly complex calculations by linking qubits in ways that classical computers can't achieve. Lastly, there's interference, which is used to manage and control qubit states in order to reach a specific answer. Think of interference as a way of amplifying correct answers and minimizing incorrect ones. By carefully setting up interference, quantum algorithms can zero in on the right solutions much faster than a traditional computer could. So, why does this matter? Why should we care about quantum computing? Well, quantum computers are expected to solve problems that would take classical computers thousands, even millions, of years to solve. Here are some key areas where quantum computing could be a game changer. First, let's talk about cryptography. Our current encryption methods rely on the fact that classical computers would take too long to crack them. But with quantum computing, these encryptions could be broken in a fraction of the time. On one hand, this presents a security risk, but on the other, it opens the door to quantum encryption, a far more secure way of protecting data. Next, consider drug discovery. Developing new medicines involves simulating molecular interactions at an atomic level. A quantum computer can simulate these interactions with incredible precision, potentially leading to faster and more effective treatments. Then there's optimization. From logistics and supply chains to finance, quantum computers could optimize complex systems by rapidly analyzing countless scenarios to find the best possible solution. Imagine airlines or delivery services reducing their fuel usage, or banks finding the most efficient ways to allocate assets, all thanks to quantum computing. And, of course, artificial intelligence stands to gain a lot from quantum computing. Quantum computers could enhance machine learning algorithms by processing vast datasets at speeds we can hardly imagine with classical computers. Now, as promising as quantum computing sounds, it's important to remember that we're still in the early days. One of the biggest challenges in this field is qubit stability. Qubits are incredibly sensitive to their environment, and even slight temperature changes or electromagnetic interference can cause them to lose their state, a phenomenon known as decoherence. Researchers are working on developing stable qubits and error-correcting techniques to make quantum computers more reliable. Another challenge is the sheer complexity of building quantum systems. Unlike classical computers, which rely on well-understood hardware, quantum computing requires extremely specialized and often fragile equipment to maintain the qubit's quantum states. This means that while there are a few functional quantum computers in the world, they're limited in power and only available to select organizations and research institutions. So, where does that leave us? Quantum computing may not be ready for everyday use just yet, but its potential is immense. As this technology continues to evolve, we can expect to see breakthroughs in science, medicine, finance, and beyond. Quantum computing represents a new frontier, one that challenges our understanding of what's computationally possible. And who knows? One day, quantum computers could become as accessible as the devices we use every day. That wraps up today's introduction to quantum computing. We hope you enjoyed this journey into the fundamentals of quantum mechanics and the possibilities it holds. If you're as excited about tech as we are, stay tuned for more episodes where we break down the most innovative technologies shaping our world. Until next time, keep exploring, keep learning, and let's unlock the future together.